Welcome to qnawire.
What's up, StatCats? In this video, we are asked to perform either a Scheffé or a Tukey test, and those are post hoc tests for a one-way ANOVA. So this is the example we're given, and these are the costs of an oven per watts of the oven. So because the sample sizes are uneven, we are going to perform a Scheffé test. So this is the test statistic. This is the formula for the test statistic. This is our CV. This is our critical value. And we are told that the alpha level for the one-way ANOVA test was performed at a 0.1 alpha level. So let's go to the Excel sheet that I have our raw data on. So I've already performed the one-way ANOVA because that's how they have the example set up. So now we are going to pair up our oven watts because a Scheffé test is a pairwise test. So we're going to pair up 1000 watts and 900 watts, 900 watts and 800 watts and 800 watts and 1000 watts. So to calculate the numerator for our test statistic, we're going to want to take the difference of the means squared. So let's go ahead and do that. So we're going to take the mean for the 1000-watt oven, and we're going to subtract the mean of the 900-watt oven, and we are going to square that value. And we're going to do that for the rest of the pairwise pairs. Oh, geez. Okay, off to a rocky start, but we can recover. So this is our numerator. So our numerator is done. And now we want to calculate our denominator. So the first thing I'm going to do is I'm actually going to calculate this portion here. And then because we already have our difference within groups, we already have our mean squared within groups already calculated. So we need to calculate the other part, which I'm going to do right here. So 1 over sample size of 1000 watt plus 1 over sample size of 900 watt. All right, so now to calculate our denominator, we are going to take our mean square within groups and we are going to multiply it by that other value we just calculated. So I'm going to go ahead and pull this. Actually, I can't pull it down. Okay, finally, to calculate our test statistic, we are going to take our numerator over our denominator, and I can pull these values down. So for 1000 and 900 watt oven, we have 2.91 for our test statistic. And for the 900 and 800, we have 8.40. And finally, for the 800 and the 1000, we have 19.28. Okay, so last thing we have to do is calculate our critical value, because that's how we are going to decide which pairs are significant. So we're just going to take our critical value from the ANOVA test and multiply it by our degrees of freedom between groups. So our critical value is 5.21. Okay, so let's go ahead and go back to our whiteboard so we can copy these numbers down, make it easy for us to reject or fail to reject. So to decide whether we have a significant pair or not, we're going to take the we're going to take the test statistic of that pair, and if it is larger than our critical value, then we can reject our null hypothesis. So that means the pair will be significant. So is 2.91 larger than 5.21? No. Is 8.40? Yes. Is 19.28? Yes. So we have two significant pairs at the 0.1 alpha level. So let's go and summarize our result. So there is sufficient evidence at the 0.1 alpha level to conclude there is a difference in mean cost between between 900 and 800 watt ovens and 800 and 1000 watt ovens. All right, that's it for this video. I hope you guys learned a lot, and I'll see you next time.